Good morning, dear students. We studied what is an acid, the various types of acids, classification of these acids, classification on their strength, on the basicity, on the source, etc. etc. Then we went on to study the physical properties of acids, chemical properties of acids, and then some important uses of acids. I hope you are keeping yourself updated. Today we are going to start with bases. What is a base? A base is a metallic oxide or a metallic hydroxide which reacts with hydronium ions or H positive ions produced by an acid to form salt and water. There are many examples of bases: cupric oxide, magnesium hydroxide, sodium hydroxide, ferric hydroxide, zinc hydroxide, and so forth. Now, let us take a look at the reaction. Whenever a base reacts with a dilute acid, it always gives you salt and water. For instance, sodium hydroxide, when reacted with hydrochloric acid, will give you salt, sodium chloride, and water, H2O. Now, base, for instance, sodium hydroxide, it produces hydroxyl ions, which are always negatively charged, OH negative ions. Whereas the acid, it always produces hydronium ions or H positive ions, which are always positively charged. So what happens is the hydroxyl ions, which are negatively charged, and it reacts with the H positive ion to form water molecule. So we also call it a neutralization reaction. Now there are different types of bases. An alkali is a basic hydroxide which, when dissolved in water, produces hydroxyl ions as the only negatively charged ions. So these are metallic hydroxides which, when dissolved in water, it yields hydroxyl ions which are always negatively charged ions. Remember, all alkalis are bases, but all bases are not alkalis. So for example, we have potassium hydroxide, sodium hydroxide, an aqueous solution of ammonium hydroxide, even calcium hydroxide. These are all alkalis because they are soluble in water. But there are bases which are insoluble in water. For example, you'll come across ferric hydroxide, cupric hydroxide, etc. etc. Now we move on to classification of bases, just as we studied classification of acids. Firstly, on the basis of strength in terms of degree of ionization. So, to what extent it ionizes in its aqueous solution, we can differentiate either it is a strong base or a weak base. For instance, strong base or alkali, what do you understand by the term strong base? They are bases or alkalis which almost completely ionize in aqueous solution. Strong bases are strong electrolytes. For example, potassium hydroxide, sodium hydroxide, and even barium hydroxide. The second one is weak base. These are bases which partially or incompletely ionize in aqueous solution. They are weak electrolytes. For example, ammonium hydroxide, calcium hydroxide, magnesium hydroxide. These are few examples of weak bases. Now we can also classify bases on the basis of acidity, just like we studied in acids chapter. Basicity, now we refer to acidity of a base. What does acidity of a base mean? Acidity of a base is the number of hydroxyl ions, that means OH negative ions, produced by one molecule of a base ionized in water. For a water insoluble base, acidity is the number of replaceable hydroxyl ions in one molecule of a base. On the basis of acidity, bases can be classified into monoacidic base, number 2 diacetic base, number 3 triacidic base. Number 1 monoacidic base. The base which furnishes or produces only one hydroxyl ion per molecule in aqueous solution is called monoacidic base. Monoacidic base. What do you understand by the term monoacidic base? The base which furnishes only one hydroxyl ion per molecule in aqueous solution is called a monoacidic base. For example, potassium hydroxide, sodium hydroxide, even ammonium hydroxide. So sodium hydroxide, for instance, in its aqueous solution, it yields only one hydroxyl ion. Hence, it is called a monoacidic base. Diacetic base. What do you understand by the term diacetic base? The base which yields two hydroxyl ions per molecule of a base in its aqueous solution is called a diacetic base. For example, calcium hydroxide, cupric hydroxide, magnesium hydroxide. So when it ionizes in water, it yields two hydroxyl ions. And the third one is a triacetic base. The base which yields three replaceable hydroxyl ions per molecule is called a triacetic base. For example, ferric oxide, aluminium hydroxide, as well as chromium hydroxide. How do we prepare bases? Preparation of bases. Number 1, from metals, which we call direct synthesis or direct combination. A metal plus oxygen gives you a base. For instance, magnesium, when it is heated in oxygen, it gives you magnesium oxide. So, you know the definition of a base. It is a metallic oxide or a metallic hydroxide. The second one is by the action of water on metals. For instance, highly reactive metals like sodium, potassium, and calcium react vigorously with cold water to give you base or an alkali plus hydrogen gas is evolved. Next is by the action of water on metallic oxides. For instance, calcium oxide, sodium oxide, potassium oxide. When you react with water, you get metallic hydroxide. Now, the next method is by double decomposition. What do you mean by double decomposition? When a salt solution is reacted with a base, it gives you basic hydroxide plus a normal salt. For instance, let's take lead nitrate solution. Let's react it with a base, for instance, ammonium hydroxide. What do I get? I get a basic hydroxide in the form of lead hydroxide and a normal salt, which is ammonium nitrate. And finally, we come to by the action of oxygen on metal sulfides. For instance, zinc sulfide. When you react with oxygen, of course, you have to heat it. You get zinc oxide and sulfur dioxide. And next one is by decomposition of salts. So, when a metal nitrate is heated, you get basic oxide and reddish brown fumes of nitrogen dioxide and oxygen gas. For instance, on heating lead nitrate crystals, you get a yellow mass of lead oxide and reddish brown fumes of nitrogen dioxide and oxygen gas is given off. Similarly, if you heat a carbonate salt like zinc carbonate, calcium carbonate, on thermal decomposition, it gives you basic oxide, which is metal oxide, and effervescence of carbon dioxide. And how do I prepare ammonium hydroxide? Since ammonia gas is highly soluble in water, it dissolves in water to give you an alkaline solution, which is ammonium hydroxide. Now let us discuss properties of bases. To begin with, physical properties. They have a bitter taste, just like acids have sour taste. They are slippery, soapy to touch, feel. Strong alkalis are corrosive in nature, so please do not taste it. They change the color of indicators. For instance, red litmus will change into blue in color. Methyl orange, which is orange in color, which turns into yellow in color. Phenolphthalein, which is a colorless solution, it changes to pink. They are strong electrolytes. Now let us discuss some chemical properties of bases. Always remember, strong alkali like potassium hydroxide, sodium hydroxide, whenever you react with carbon dioxide gas, you get metallic carbonates plus water. For instance, sodium hydroxide, when reacted with carbon dioxide, will give you sodium carbonate and water. Number 2, bases neutralize acids to form salt and water, which we also call neutralization reaction. Let's take copper oxide. When reacted with sulfuric acid, it gives you salt, copper sulfate plus water. Similarly, ammonium salt plus alkali will always give you salt, water, and ammonia gas, which you're going to study in detail in ammonia chapter. Now, most important part of this chapter is, what do you observe when you react, let's say, certain bases like sodium hydroxide or ammonium hydroxide with metallic salt solution. For instance, copper sulfate solution, when reacted with ammonium hydroxide solution, you see that a blue precipitate of copper hydroxide is formed. Similarly, zinc sulfate solution, when reacted with sodium hydroxide solution, you see a gelatinous white precipitate of zinc hydroxide. Similarly, lead nitrate solution, when reacted with ammonium hydroxide solution, you find a white precipitate of lead hydroxide. So this you are also going to study in detail in the coming chapter, and that is analytical chemistry. Now let us come to the end of the chapter, end of this basis chapter. What are the important uses of certain bases? First, sodium hydroxide is used in the manufacture of soap. Number 2, calcium hydroxide is used for bleaching powder. Then mortar, softening of hard water, neutralizing acids in the soil and in water supplies. Potassium hydroxide is used in alkaline batteries. Magnesium hydroxide is used as an antacid to neutralize acidity caused in the stomach. For instance, if you overeat due to indigestion, you suffer from acidity. So that time the doctor gives you Digen gel, let's say, or maybe Gelusil. So what is the chemical compound that it contains? Magnesium hydroxide. Next is aluminium hydroxide is used as a foaming agent in fire extinguishers. Then ammonium hydroxide is used to remove grease stains and also stains from clothes. Then finally it is magnesia. It is used in making refractory bricks. Now that brings us to the end of the chapter bases. Please revise the lesson thoroughly, then attempt the questions that are given in the assignment. Thank you. All the best.